In Concept D, we're going to be focusing on unit conversions using a process called dimensional analysis and working with the metric system. At the end of this lesson, you should hopefully be able to use reference tables to create conversion factors, so I make sure you have it out and on the front cover looking at Table C. You're also going to be able to set up and calculate unit conversions using a method called dimensional analysis. So a little bit of review for the metric system. The base units we'll be working with a lot this year are meters, liters, and grams. Our metric system is based on a base of 10, and our prefixes are used to determine the magnitude of a particular unit. So kilo means 1,000, centime means 1/100th. Our prefixes can be found on Table C. We can use these to create multiples and subdivisions of any base unit of measure. Units also act just like numbers. So if I'm completing this question, grams over liters is going to stay in our answer of grams per liters. Moles are going to act just like numbers. That moles, if we have one in the numerator and one in the denominator, they cancel out, so I'm left with a unit of grams. Now, when completing unit conversions back in middle school, you guys use a little bit of a shortcut where you jump the decimal point, or you might remember it as the phrase, King Henry died unexpectedly drinking chocolate milk. We're not going to be doing that here. It's not just about getting the correct answer. What I'm more concerned with is if you can do the method or the dimensional analysis to get the answer. That's where a lot of the points are going to be, is that method. So this conversion factor that we talk about is actually just an equality. Two values that are equal to each other, and thus together, and dividing them, equal 1. So we're concerned with the two prefixes, how they relate to one another, and the difference in magnitude between them. On Table C, when I talk about the magnitude of the number, or the prefix I should say, I'm looking at the exponent of 10. So the magnitude of deci is -1. Or the magnitude of micro is -6. So make sure, again, you have Table C out. By using Table C to determine the magnitude, it is important to note that if you're working with no prefix, so you're working with just meters or just liters, then we consider a power of 0 or 10 to the 0. When using the difference between units to create the conversion factor, remember it takes many smaller units to equal one of a larger unit. So just keep that in mind as we come up with these conversion factors. Two math concepts that I want to just point out to you, just to bring this back up into your mind so it helps make these conversion factors and dimensional analysis a little bit easier. If I give you this problem, I think most of you guys would notice the 3's in the numerator and denominator and know that you can just cancel those out. Same thing with units using dimensional analysis. If I have centimeters in the numerator and denominator, or meters in the numerator and denominator, I can cancel them out and be left with kilometers. So keep that in mind for this dimensional analysis. Another important background piece to this is if I have 4 is equal to 4, which all of you know, it's two values that are equal to each other. If I divide them, it's equal to 1. Same thing, if 12 inches is equal to 1 foot, if I divide 12 inches by 1 foot, I get 1, or 1 foot by 12 inches, I also get 1. So when we use these conversion factors, which are equalities, two values equal to each other, it's just like taking our original value that we're converting and multiplying it by 1, but instead we're using those units to convert it. Alright, so let's see if we can actually put that information into some examples. And really it's the examples that will drill in how to complete this method. So we're going to convert 5.6 meters to kilometers. So we're first going to determine the conversion factor. We look at our given unit and our target unit. Our given unit has no prefix, so the magnitude is 10 to the 0. Kilometers have the prefix kilo, which has a magnitude of 10 to the 3rd. The difference between those units is the difference in the exponents. So you can use a numbered line if you need to. Jumping from 0 to 3, I jump 3 times, so I have a difference of 3 units. I have 3 powers of 10 difference. That means I have a 1 with 3 zeros, or 1,000 as my number that I get from looking at the magnitudes between the two prefixes. That means my conversion factor is many of the small is equal to 1 of the large. 1,000 meters is equal to 1 kilometer, or 1,000 meters per kilometer. So that's the first step. Your first goal of this lesson is being able to come up with that conversion factor. Now let's apply it in dimensional analysis, which is the next step. I always start with whatever I'm given. That's going to hold and be the case the entire year. So 5.6 meters. You can place a 1 here in kind of like these railroad tracks if needed. This conversion factor is going to be placed in this next column in our railroad tracks. Whatever we start with as our unit has to be in the bottom. We said that we had 1,000 meters per 1 kilometer. So the 1,000 meters is going to go in the denominator, and the 1 kilometer is going to go in the numerator. Okay, and that's just setting up our dimensional analysis. Now we go through and cancel out any units in the numerator and denominator. We always multiply across the top, divide by any numbers on the bottom. So in this case, we get 0.0056 kilometers. The number of sig figs in our answer, or our, given unit is going to be reflected in our target or ending amount. So I started with 2, I end with 2. Alright, example number 2. Here we have two prefixes that we're comparing. Centi is 10 to the negative 2, milli is 10 to the negative 3. So I have 1 power difference between them, or 1 with 1 0. So the smaller unit is milligrams. 10 milligrams is equal to 1 centigram, or 10 milligrams per centigram. Okay, so that's again the first objective of coming up with that conversion factor. So let's go on to the second piece of this, which is actually using dimensional analysis to convert. Always start with whatever you're given, 12.3 centigrams. The next column, we're going to fill in our conversion factor. Since I started with centigrams, the 1 centigram has to go in the bottom, and that is equal to 10 milligrams. Again, these two values have to be equal to one another. I'm going to now solve for my answer. The repeating units in the numerator and denominator get canceled out. I multiply across the top, divide by any numbers in the bottom, and I get an answer of 123 milligrams. All right, if you feel good, try out example number 3 on your own. If not, I'm going to walk you through this one. You'll have one other chance to practice. All right, I have milli and our kilo for kilometers. Milli is 10 to the negative 3, kilo is 10 to the 3rd. So I have a difference of 6 powers of 10, or a 1 in 6 zeros. Remember, many of the small equal 1 of the large. 1 million millimeters is equal to 1 kilometer. So again, we've accomplished creating that conversion factor. So now let's put it to use. Always start with your given value. Because my given value has millimeters, the 1 million millimeters goes in the bottom, and that's equal to 1 kilometer. These two values should be equal to each other. Getting rid of our repeating units in the numerator and denominator, we get rid of millimeters, multiply any numbers across the top, divide by the bottom, and we get 0.012005 kilometers. And again, my 5 sig figs in my starting amount is reflected in my ending amount. All right, see if you can try out this next one on your own. I didn't give you the chart. You could create it if it's helpful, or come up with your own way of organizing the information, and then come back to it once you've completed it. So you're converting 59.7 liters to deciliters. I'm going to look at my two prefixes, or in this case, my base unit of liters. So 10 to the 0 and 10 to the negative 1. I have 1 power difference between them, which gives me a number of 10. The smaller unit is deciliters, so 10 deciliters is equal to 1 liter. I'm going to start with what I'm given, which is 59.7 liters. Because I start with liters, I have to put the 1 liter in the denominator, which is equal to 10 deciliters. I'm going to cross out the liters, because there's 1 in the numerator, 1 in the denominator, multiply across the top, divide by the bottom, and I get 597 deciliters. Okay. I know that these conversion factors and using dimensional analysis can be very challenging to students. Remember, we're making neurons as we work on this. So what I would suggest is, now that you have your notes completed, go back and just watch the examples again and see if you can pick up on any details that you might not have when you were going through and taking your notes. We're going to be practicing this for 2 days, so you will have plenty of time for that repetition and practice that's needed so that you can again become better at this, even though you might find it a little bit difficult in the beginning. All right, well, you are all set. Have a wonderful evening.